Dear students, now today we are going to learn about the inner tensor, inner product of tensors, Quotient Law. Let us look what do you mean by inner product of tensors and Quotient Law. Now the inner product involves two steps. First, we have to find outer product as we learned in the previous PPT, the outer product, and then go for contraction. Okay, so we know both how to find the outer product and how to find the contraction of vectors. If Aij and Bk are two tensors, of course the contravariant and covariant tensors, then the outer product is, we know this, their outer product is known as Cijk. This is a mixed tensor, Cijk. Now putting k is equal to I, minded, if we want to put k is equal to I, okay, k is equal to I, or k is equal to j. It is our option. We may put anyone, either k is equal to I or k is equal to j. Then the result is the inner product of the tensor Aij and Bk. It means the inner product of tensor obeys commutative and associative, both law. It is also the point to remember that this inner product obeys the commutative and associative, both the algebraic law. Now, one example for practice, so that any inner product of tensor APR and BQST is a tensor of rank 3. And how you will prove this? Let us suppose APR and BQST are the tensors, and we may define these tensors as Aij is equal to del x bar I, you know, del xp, del xr, del x bar j, APR, and BLMN is equal to Bx del xl, del xq in the component form, del xm, del xs, del xt over del x bar n, and BQST. The outer multiplication may be done like this: A bar I j B L M N. So you take this part from here and this part from here, then you put here. This is like this. You check this, and again this part is here. So you put here. Okay. So you may rewrite the expression as this, and now further, uh, just you contract. You can contract by assuming I is equal to n. So if I is equal to n here, just you put here, this is I is equal to n, then certainly the term will be changed. Here will be del x bar I, here also del x bar I, because n is equal to I here. Okay, so it means just you look this relation and you know the Kronecker delta, because Kronecker delta, you know, del Tp is equal to del x bar I over del xp, del xt over del xip. You know this relation. Okay, so you may replace this equation as del xr over del x bar j, just to check here this relation here. So del x bar L, del x Q, del x bar M, del xs, and then Kronecker delta del Tp, APR, and BQST. You know this, we have already know about this tensor. This is the value is 1, and then you may write this from here to here. In place of this whole, you may write like this. It means it is clear that APR BQST is a tensor of rank 3. Okay, that is already clear, and you have established that this is the tensor of the rank 3. Okay, now one of the best application of inner product is Quotient Law, and this is very important law, which is known as Quotient Law. So what is the statement of Quotient Law? If a quantity capital X is inner multiplied by an arbitrary tensor and the obtained result is a tensor, then capital X, that quantity, is also a tensor. This law is known as Quotient Law. Okay, so in other words, as I said, this law is very important. How? Because by this law, we may test, with this very important sentence, we may test whether a given quantity is a tensor or not. This is a kind of tool when in tensor, when we use to check the quantity if this is a tensor or not. How? Let us suppose we are given a quantity capital X and we do not know whether capital X is a tensor or not. To test capital X, we will take inner product. We will take inner product of capital X with an arbitrary tensor. If this inner product is a tensor, then capital X is also a tensor. Okay, so which is the statement of this Quotient law, and if this is fulfilled, then we can say if this is according to the Quotient law. So this is a very important law which is useful for further calculation in tensor calculus.